Hi guys, let's start the new video which is exercise 5b. Before we start, let's quickly revise what we've learned in exercise 5a. We said the equation of the form ax squared plus bx plus c is equal to 0 is a quadratic equation where the maximum power is 2, one variable, and a, b, c belong to real number and a is not equal to 0. That's something that we've done till now. Now let's figure out why do we need to read quadratic equations. Various uses. Number one, if you remember your equations of motion from class 9, you remember v square is equal to u square plus 2as and s is equal to ut plus half at square. Both these will get converted into a quadratic equation and you need to figure out how to solve them. That helps us in a lot in physics in the equations of motion to figure out distance traveled, final velocity, initial velocity and other things. The two pictures that you see, I hope you notice this shape here and you notice this shape that was a bridge and this is a roller coaster. This shape is peculiar to a quadratic equation. How? Let's try and understand. So this is the graph of a linear equation. We've done this in class 9. The linear equation was of the form y is equal to mx plus c. This is the linear equation. We take various values of x and y, or rather various values of x. We'll get the value of y which we plot. It would be a straight line. Now on the right hand side, the graph is of a quadratic equation. So if I take fx, the function of x equal to ax square plus bx plus c, and if I change the value of x and I plot it on the x and y coordinate, I will get a curve. I will not get a straight line, I'll get a curve. So this specific graph here is for the quadratic equation y is equal to x square minus x minus 2. This is basically a function of x. So if x is equal to 1, the value that I'll get will be 1 minus 1 minus 2, which means y would be equal to negative 2. So I hope you remember how to plot it. We take x and y, and one value of x I've taken as 1, the value of y is negative 2. So value of x is 1, y is negative 2. That's the point that I plotted. If x is equal to 2, what I'll get would be 4 minus 2, that's 0. So x is equal to 2, I'll get the value of y as 0, which is this point that has been plotted. Next, if I take x is equal to negative 1, the value that I get is negative 1 square minus negative 1 minus 2. That's 1 plus 1 minus 2, which is equal to 2 minus 2, 0, which is negative 1 with 0. So this is that plot that this is the number point that has been plotted. If you join it, you will get it in the form of a curve, which is the one that you see here. So all these curves are basically a quadratic equation. I hope it gives you some basic idea. In any case, plotting is not in your syllabus for this year. Let's look at the next question, or rather the next concept. The concept says we can figure out the nature of roots or the type of roots for a quadratic equation by trying to figure out the discriminant. Now what is discriminant? Well, I have written D. D is equal to discriminant. We've done this in class 9 also. It is also written as delta by some people. D is equal to b square minus 4ac of the quadratic equation ax square plus bx plus c is equal to 0. So if you find the value of discriminant, you would be able to figure out the nature of roots. So when d is equal to 0, this is the kind of a graph that I have shown you here. When delta is equal to 0 or discriminant is 0, you would get real and equal roots, which means you will have the roots are, or the solution is real and equal when d is equal to 0. And what's d? D is equal to b square minus 4ac. What does this mean? It means that if d is equal to 0, you will get only one solution, or rather the solutions will be equal. There will be one solution and the solution is equal. Next, when d is more than 0, which means this is the kind of a graph that I had plotted in the previous slide as well, you will get two solutions and both these solutions will be different, which means these are real solutions and unequal. So these are two solutions, both are real and unequal. And when d is less than 0, which is the graph that you see in orange here, now this graph does not meet the x-axis at all, right? I hope you notice this graph here does not meet the x-axis at all, which means for no real value of x, quadratic equation is valid, which means no real value of x satisfies this quadratic equation, which means the roots are imaginary. Let's do this again. When d is equal to 0, the roots are real and equal. When d is more than 0, which means the roots are real and unequal, which is case 2 here. This was case 1. And when d is less than 0, which is the roots are imaginary, which means the curve which we draw will not even meet the x-axis. Perfect. Now let's look at some questions and see how does this help us in solving questions. So let's look at question number 1, part 2. It says without solving, comment on the nature of roots. So we'll again have to look at d discriminant and then see what's the value of discriminant. So how would you write the answer? Comparing with ax squared plus bx plus c is equal to 0. I get the value of a as 6, b as negative 13 and c as 4. This is 6, negative 13 and 4. So d is equal to b square minus 4ac, which will be equal to negative 13 square minus 4 into 6 into 4. That's 169 minus 24 into 4. That's 96, which is equal to, that's 4 and 69, 73. Now since d is more than 0, therefore roots are real and unequal. Important to realize this and remember this. There are three conditions. When d is equal to 0, roots are real and equal. When d is more than 0, roots are real and unequal. And when d is less than 0, roots are imaginary. Good. Let's look at question number 1, part 3. It says, again, we need to comment on the nature of roots. So a will be equal to 25, b will be equal to negative 10, and c would be equal to 1. So d, which is equal to b square minus 4ac, would be equal to negative 10 square minus 4 into 25 into 1. This is 100 minus 100, which is equal to 0. Since d is equal to 0, therefore the solutions or the roots are real and equal. Good. Simple, isn't it? Yes. Let's look at the question number 1, part 6. It says 2x squared plus 8x plus 9. Again, comparing, we get a is equal to 2, b is equal to 8, and c is equal to 9. So discriminant, which is equal to b square minus 4ac, would be equal to 8 square minus 4 into 2 into 9. That's 64 minus 4 into 2, 8 into 9, 72, which is equal to negative 8. Now since d is less than 0, therefore roots are imaginary. They are not real. So roots are imaginary. I hope this part is very simple and clear. We need to remember the three things. When d is equal to 0, roots are real and equal. D is more than 0, roots are real and unequal. And d is less than 0, then the roots are imaginary. Let's look at the next question. The next question is question number 2. This is a board question, appeared in 2013. It says question number 2, part 2. It says find the value of p if the roots are equal, which means the solution is given that the roots are equal. Now since roots are equal, which means therefore discriminant is equal to 0. Now comparing with ax squared plus bx plus c is equal to 0. we get a is equal to 1, the coefficient of x square is 1, coefficient of x is p minus 3, and the constant is p. Perfect. So d, which is equal to b square minus 4ac, is equal to 0. That's given. Let's substitute values. So it's p minus 3 whole square minus 4 times a, which is 1, multiplied with c, which is p, is equal to 0. Let's open the bracket, and I get p square plus 9 minus 6p. Right? P square plus 9 minus 6p minus 4p is equal to 0, which means p square minus 10p plus 9 is equal to 0. Now I'll have to split the middle term. The factors of, I need to find factors of 9, the sum of which is negative 10, which means 9 and 1. So negative 9 and negative 1. So I split negative 10 as negative 1 and negative 9 is equal to 0. Grouping these together, I get p times p minus 1 minus 9 times p minus 1 is equal to 0. P minus 1 times p minus 9 is equal to 0, which means p minus 1 is equal to 0 or p minus 9 is equal to 0, which means p is equal to 1 or p is equal to 9. So the solution set is p is equal to 1 or 9. These are the two possible options. Good. Very simple, but you need to remember only one thing. D is equal to 0 means roots are real and equal. Next, D is more than 0, roots are real and unequal, and if D is less than 0, roots are imaginary. Most important thing about this exercise. Let's look at the next question. The next question that we have is question number 4. Question number 4 says, find the value of m if the following equation has equal roots. Okay. Again, the roots are equal, which means d is equal to 0. Comparing with ax square plus bx plus c is equal to 0, we get a is equal to m minus 2, which is basically the coefficient of x square, b is equal to negative 5 plus m, and c is equal to 16. That's a common mistake which students would do of trying to figure out what is b. So since there is a negative outside this bracket, I have kept it as outside. When we square it, my life will become simpler. Now since roots are equal, therefore d is equal to 0. So d is equal to b square minus 4ac is equal to 0. Let's substitute values. B is negative 5 plus m whole square minus 4 multiplied with a, which is m minus 2, multiplied with c, which is 16. This is equal to 0. Let's open bracket. So this is negative number to the square, so it's positive in any case. So this is basically nothing but 5 plus m whole square minus 4 into 16. That's 64 times m minus 2 is equal to 0. Now let's open the bracket. This is 25 plus m square plus 10m minus 64m plus 64 into 2, that's 128. Let's just check. Yes, that's 128 is equal to 0. Okay, so this is m square, 10 minus 64, that's negative 54m plus 128 and 25, that's 148, 153. So plus 153 is equal to 0. Again, I'll have to split the middle term. The product of which should be 153. So that's 153 would be 3 into 51, qualifies this condition as well. So m square minus m minus 53, minus 3 and 51, minus 3m minus 51m. 153 would be 3 into 51, both negative because I need the sum to be negative, plus 153 is equal to 0. Grouping it like this gives me m times m minus 3 minus 51 times m minus 3 is equal to 0. M minus 3 times m minus 51 is equal to 0. M is equal to 3 or m is equal to 51. We need to find the value of m. That's the question. Done. Right, so again I'll revise. You need to remember three things. D is equal to 0, roots are real and equal. D is more than 0, roots are real and unequal, and D is less than 0, roots are imaginary. Good, that brings me to the last question of this exercise. Let's look at that question, which is question number 5. Question number 5 says, again this is a board question, appeared in 2015. Find the value of k for which the equation has distinct and real roots. So distinct would mean unequal, which means we are looking at d is more than 0. So comparing with ax square plus bx plus c is equal to 0, we get a is equal to 3, b is equal to negative 6 and c is equal to k. Since roots are real and distinct, it means therefore d is more than 0, which means d is equal to b square minus 4ac is more than 0. Substituting values, b, which is negative 6 whole square minus 4 times a, which is 3, multiplied with c, which is k, is more than 0, which means 36 minus 12k is more than 0, which means 36 is more than 12k, which means 3 is more than k, which means k is less than 3. That's the answer. Value of k for which equation has distinct and real roots basically means k has to be less than 3. That brings me to an end of this video. Homework questions for you. That would be question number 3 and question number 2 part 1. That's about it. Thank you so much. Take care. Be safe. I'll see you with the next video. Bye bye.